All right. Well, thank you guys for sticking around and for the invitation here to come and talk to you about some work I've been doing. So my name is Dave Lampert. I'm a relatively new professor, although getting less new now, at Illinois Institute of Technology. I'm an environmental engineer by training. I do work on water quality on a wide variety of issues, and that includes PFAS. I've got some ongoing work on PFAS, harmful algal blooms. And then for this project, we were looking at stormwater management. And this project really was a great opportunity for me, and I thank the Sea Grant for supporting it, to kind of combine together a couple ideas I was interested in getting involved with here since I moved to Chicago. So I was formerly a faculty member at Oklahoma State University, and before that I was actually at Argonne National Lab here. So I was in Chicago for a while doing work on energy water things. But anyway, one of the big issues we have in Chicago is with stormwater management, and then there's a lot of interest in improving water outcomes for disadvantaged communities, and as we know, disadvantaged communities tend to have more issues with water than other communities, and so really this is kind of combining two of those things together, or that the disadvantaged community environmental justice aspect of that, along with building a smart water system. And so smart being like trying to use sensors and data to try to figure out how we could get more information about water systems and get them to work better. And so our objectives here in the project were to build and implement some water quality sensors for monitoring pollution, and then develop a stormwater model somewhere where we knew that was kind of a disadvantaged community, build collaborations, and then submit a proposal. Basically this is like a seed grant to try to do some other things. So I guess next slide. The deliverables then of what we were trying to do was to build this submersible stormwater system that we could put into the sewer and collect data. And so we've been doing a lot of work on trying to figure out how to do that. And then we needed a study area to focus on. So I got into contact with the Metro Water Reclamation District that does a lot of the stormwater management issues in the Chicago area. And they had suggested that I speak with Harvey, which is down here just south, probably about halfway between here and downtown Chicago, if you were to drive back. And so they were already working on a SWIM model, so we started working with their SWIM model some. And SWIM is basically a tool that the EPA has helped develop that you can use to predict how water is going to flow through a stormwater system, and also to look at the water quality there. So we've been working on the submersible system. As part of the environmental justice aspect of this, I got some internal seed funding from our vice provost for research to work with a social scientist, and we used that to actually do a little pilot survey looking at what people's perceptions were, a variety of issues, but including one that I picked here on stormwater flooding issues in their community. And we did find that in general, we had spatial data on where these individuals were located, which this was all done through an online survey. And again, I worked with this with a social scientist on this, but there's a wide variety of issues that people feel like affect them, including climate change, and then also issues with governmental management and lack of attention to the infrastructure. So it was kind of an interesting finding. We're still working on what that data means. But we did that in hopes of developing a larger proposal, which we put together to NSF. So NSF had a call for stuff on climate-related impacts on communities through their PIRE program, which is an international research, and IIT has a close collaboration with the Polytechnic University of Madrid. And so we put together a big proposal back in May. Unfortunately, it was not funded, although we were very, very close. We got fund if possible, but then we didn't make the final selection. But anyway, it was a great opportunity for us to kind of get some ideas together. And I got to know some other people from the Illinois Water Survey, because we needed climate science. We don't have geoscience at IIT, so I needed somebody that actually knows about climate change to help me with that. Anyway, so those are some of our deliverables. Next slide, I guess we've got a little bit of a demo of this submersible water system we've been working on. And so what we really needed was something that we could put down into the sewer that could monitor both the flow and hopefully eventually the water quality. And that presents a variety of challenges, like how do you put it there, how do you keep it there? And so we built, as a starting point, an Arduino system there on the lower left with two sensors, one of them that can measure the pressure, which tells you how far the water is above it, and another one that can look down at the water. And then we kind of deployed them here in this little fish tank. And what we did is, looking at from the top left, 1, 2, 3, 4, we basically filled the water up more, and then we're monitoring them with the two sensors. And the one was able to show us how the depth was increasing over time, and the other one was able to show us how far the water was down below. This system needs to go in the sewer again, so we've been working on trying to figure out how to put that in a waterproof case so that if it gets submerged, it'll still work. And that's, I guess I got a picture on the next slide, the last slide here, of a waterproof case. So we've got one that we were able to test, put it in a tank over the weekend, and push some sensors out through that, and was able to stay dry. And then we're trying to figure out how to put together a network that we can use so that we could gather lots of data from throughout the sewer system with this. We also want to add in some tryptophan sensing that we can use to monitor sewage levels, and then try to figure out how to use these models to look at alternative land use policies that would be more equitable and improve stormwater management. So with that, thank you very much, and I'll be happy to take questions at the end.